Hello, and welcome to this presentation, Getting Started with the EVS1000 COM Mode. In this presentation, we'll show you how to make measurements of analog COM signals using Rohde and Schwarz EVS1000 series analyzers. This presentation assumes a basic familiarity with Rohde and Schwarz EVS1000 series analyzers. If you're unfamiliar with the EVS1000, or if you'd like a review, you might want to watch the presentation Getting Started with the EVS1000 General Overview before continuing with this presentation. COM analysis is enabled by software option Case 6 and provides information on the level, frequency, and modulation parameters of COM signals at VHF and UHF. Both civilian airband and military frequencies with channel spacing of 25 kHz or 8.33 kHz can be analyzed by the EVS. Measurements are performed on signals consisting of either one or two carriers, both of which must be modulated with a 1000 or 1200 Hz tone. Measurement data can also be recorded for viewing on the EVS or for external analysis. To access COM analysis mode on the EVSg1000, simply press the Mode Hard key on the front of the instrument and select COM. If operating the EVS over VNC, press M and then use the down arrow to scroll through the list of available analysis modes. The first step in COM mode is configuring frequencies, which is done using the Measure key or by pressing A in VNC mode. This allows us to select the channel configuration, channel offsets, and tone frequency. There are four possible channel configurations. 1F simply measures at the configured frequency. This is entered using the channel frequency hard key or by pressing Q in VNC mode. 2F measures simultaneously at two frequencies. Each frequency is offset from the configured channel by the TX channel offset parameters. Options 2F-TX1 and 2F-TX2 measure either the lower or upper of these two offset frequencies. And finally, the frequency of the tone used to modulate the channel, or channels, must also be given. This is either 1000 Hz or 1200 Hz. Let's look at these different configurations. For F1, we see measurements being performed only on a single carrier, and for 2F, we can see two carriers and measurement parameters for each. The harmonic distortion measurements K2 through K4 and total harmonic distortion, which we'll discuss in a few moments, are shown for the combination or the sum of both carriers. 2F-TX1 and 2F-TX2 modes also show measurements for both carriers, but the harmonic distortion parameters in these cases are calculated for only one of the two carriers instead of the sum of both carriers. There are two measurement results view in COM mode. These are Main and Recording. We'll start by looking at the Main Analysis view. The main COM analysis view is divided into three sections: the level and frequency display, which provides information on the power and frequency of the received signal; the IF spectrum view, which shows power as a function of frequency; and the main numerical results, which can be configured to show various measurements and parameters of the received signal. As mentioned a moment ago, the level and frequency display shows the power and frequency of the input signal, with power shown as an absolute value in dBm and frequency shown as an offset in Hertz from the nominal or configured COM frequency. If a dual channel mode is chosen, powers and frequencies are displayed for each channel individually. The bar graph indicates the overload state. Green means no overload, yellow indicates an approaching overload, and red indicates that an overload is occurring. If an overload condition does occur, different messages will appear depending on the type of overload. For example, here both RF and ADC overloads are occurring. Regardless of the cause of the overload, the solution is to reduce or attenuate the input level, and this can be done by setting RF attenuation to either normal or low distortion. Please see the EVS1000 General Overview presentation for more details on configuring RF attenuation. The IF spectrum preview provides a plot of power versus frequency, similar to a spectrum analyzer display. The center of the display, or the zero frequency, is the nominal channel frequency, and the frequency range, or span, is set to the measured bandwidth. The EVS chooses a power range that will display both the peak and the noise simultaneously. Shading is used to indicate the channel or channels. The main application of the IF spectrum preview is verifying that measurement settings are appropriate. For example, we can use the IF spectrum to see if COM signals are present, or if there is noise or other types of interference in addition to the COM signal. Although the EVS automatically chooses the frequency range or span, RF spectrum mode can be used to choose a larger span if needed. This is covered in a separate presentation. Note that if RF spectrum mode is chosen, the current settings, such as channel frequency, are transferred to that mode. The numerical results for COM signals are based on the signals being modulated with either a 1000 or 1200 Hz tone. These measurements include the AM modulation percentage, the measured tone frequency, individual harmonic distortion measurements for the second, third, and fourth harmonic, and the total harmonic distortion. As mentioned earlier, dual carrier measurements will provide results for either the sum of both carriers or for each carrier individually, depending on configuration. The last view we'll look at is the recording view, which displays and stores COM measurement data in a tabular format. If GPS data is available, this data is also stored with the COM measurement data. Data is also stored with so-called status flags. Please see the separate presentation, Getting Started with the EVS1000 Data Recording, for more details and step-by-step instructions on logging and exporting measured data. In this presentation, we've covered COM analysis mode, which is enabled by software option K6. This option performs measurements on either one or two carriers simultaneously, including modulation and frequency parameters, as well as various distortion measurements. Additional displays of the received signal level and frequency, as well as a spectrum view, can be used to verify the presence of the COM signal and/or the presence of other signals or noise. All measurement data can be logged together with GPS time and position information. And finally, configuration of COM analysis is very easy. Simply enter the COM frequency, configure the number of carriers and their offsets, and specify the modulating tone frequency. This concludes our presentation, Getting Started with the EVS1000 COM mode. If you'd like to learn more about the EVS1000 or other avionics-related topics, please see the links in the video description. Thanks for watching.